Hey guys, we're starting a new unit. We're starting our probability unit. Sometimes statisticians who have come from calculus really love probability because they get their answer, that correct answer, and there's not a lot of in between, okay? So let's get going. Let's talk about probability. And the first thing is we want to just talk about some basics of probability, how we interpret probability, how we can use simulation to estimate probability, and then finally we want to talk about some probability rules today, okay? So the first thing I want you to know is just, well, like, what is probability, okay? And you don't necessarily need to write down this definition, but there's some important things you need to know from it. So a probability of any outcome of a chance process is a number between 0 and 1, okay, so that's one thing we need to know, that describes the outcome that would occur in a very long series of repetitions. That means we need a large sample size when we're talking about probability, okay? Let's apply this right now. What I want to do with this slide is I want to make sure that you can just interpret what a probability means and then talk about variation in statistics, okay? So part 8 says explain what probability of 0.61 means in this setting. Okay. What that means there, we would say 0.61 means that we would predict if you asked a large sample of US adults whether they eat breakfast, about 61% of them will answer yes. Okay, so what did I do? I took that 0.61, I changed it then to a percentage because oftentimes we will think about probabilities as percentages, okay? When we first find them, obviously, or calculate them, they are between 0 and 1. We told the story, okay? 0.61 means that we would predict, okay, because it is a prediction. If you asked a large sample of US adults, there's our large sample size, guys, right? I talked about that right here. A very long series of repetitions. So we're not saying a very long series of repetitions because we're putting in context. If we ask a large sample of US adults, here's our context now. Whether they eat breakfast, that's what the story is about. Whether they eat breakfast, right? About 61% of them will answer yes. Again, using this about right here, that's important. Why? Because that's what a probability is. It's not exactly going to happen. Let's think about it if we would flip a coin. If we would flip a coin 100 times, what would we expect to happen? It should be 50% of the times we should flip heads. So we would say 0.51 means that we would predict, right? If we flipped a coin many, many times, about 50% of them will land heads. Will it exactly be 50%? Not every time. Sometimes. Let's think of it this way. I'm bored at home. It's a pandemic right now. I'm not doing a whole lot. I decide to flip a coin 100 times tonight. I record what I get. It's 48 of those land heads. Tomorrow I do it again, 100 times. The next day, 51 of them land heads. I do it again the next day, 50 of them land heads. The probability doesn't mean that will exactly happen, okay? And that's what this is also getting at here, is about. That also leads us to the next question. Why does this probability say 100 US adults are chosen at random? Exactly 61 of them will usually eat breakfast. Just like what I said with this flipping of a coin. There's variation in statistics. When things happen, there's variation. So how would I answer this question? I would say in a random sample of 100 adults, we would expect 61 of them to say yes, but the exact number will vary from sample to sample. Again, variation in statistics. Okay, last thing I want to talk about, you're going to be doing a lot of calculation, and just I want to throw this out there before we move on. When we are calculating probability, sometimes we go you're like punching in numbers and you're going fast and you get this answer here, 2.62 E negative 4. It will actually look like something like 2.62 blah, 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 E negative 4. Please, please, please watch out for this. What happens is I get people who think really quick and they go really fast, and then they write down the answer as 2.62. The issue is, remember, when we're calculating probability, it has to be between 0 and 1. This E negative 4 is actually scientific notation. And so what we want to do is 2.62 times 10 to the negative 4. We're going to move that decimal back 1, 2, 3, 4 to the left because it's negative, and that gives us this probability right here. If you get an e -5, so that would be times 10 to the -5th power, you don't need to move it back 5 places. You can just say the probability is approximately 0. All right, let's move on. I do want to talk about, kind of got out of here, the law of large numbers. The law of large numbers states that simulated, so also known as empirical, probabilities tend to get closer to the true probability as the number of trials increase. As the number of trials increases, okay? We want to get into simulation now. So that's going to be part 2 of our video because I'm trying to keep the videos, you know, anywhere from no more than 10 minutes. So if I go on to simulation, it's going to go longer. So video part 1 is done. We're at 6 minutes and we're going to look at now simulation. Before you stop this video, make sure that you get the law of large numbers definition down. The law of large numbers states that simulated probabilities tend to get closer to the true probability as the number of trials increases.